Hello students, I hope that you are good, well and fine. In today's chapter, we will be seeing miscellaneous exercise on chapter 10, Vector Algebra. Okay. So the first question of miscellaneous exercise says that write down a unit vector in xy plane making an angle of 30 degree with a positive direction of x-axis. So let's see quickly that if r is a unit vector in xy plane, then the r can be rewritten as cos theta I hat plus sin theta j hat. Here theta is the angle made by the unit vector with the positive direction of x-axis. Therefore, theta is already given to you that 30 degree. This means r vector, the component form will be root 3 by 2 I hat plus half j hat. So the required unit vector must be what? Root 3 by 2 I hat plus I half j hat. Why I am saying that this is your unit vector? Because if you try to see the magnitude will be what? Just 1. Okay, you can verify that. Okay, now the second problem. Find the scalar component and magnitude of the vector joining the points P and Q. So first of all, you have to find the vectors joining the points. So the point, okay, so position vector of Q minus position vector of P to obtain your PQ vector. Okay, this means you will have x2 minus x1 I hat plus y2 minus y1 j hat plus z2 minus z1 k hat. This means this will be your PQ vector. Now magnitude will be, the magnitude for this vector will be this. Root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Clear? Okay. But so you have found out the magnitude, you have found out the scalar component. The scalar component will be x2 minus x1, y2 minus y1 and z2 minus z1. The magnitude will be this. So this will be your answer. Clear? Now, third problem. A girl walks 4 km towards west. Then she walks 3 km in a direction of 30 degree east of north and stops. Determine the girl's displacement from her initial position of departure. So let's see. Let's try to visualize it. So first of all, girls walk towards west 4 km as you can see. So west direction here 4 km. Originally she was at O. Now she is standing at point A as you can see in this picture. Okay. Now she walks 3 km east of north. Okay, east of north making 30 degree as you can see. So east of north, this means your this angle, that if you try to make a line going through this point A and perpendicular to this OA, you will have this, and this angle will be your 30 degree. This means this angle, the angle OAB, will be your 60 degree. B point is what? That after walking in a direction, after walking 3 km in a direction 30 degree east of north, then stops, the stopping point will be your P. So angle OAB will be 60 degree. Clear? So this means this you have to find out this OB magnitude in terms of, if you have OB vector, then you have to find out the magnitude. Clear? So let's see. Now OA is just minus 4 I hat. Okay. AB will be, as you can see, OA. Okay. Clear? AB vector will be what? I hat times magnitude of AB cos 60 plus j hat times magnitude of AB sin 60. This means magnitude of AB is what? You already know, 3. So this means 3 I hat plus 3 I hat multiply half. This means 3 by 2 I hat, and this will be 3 root 3 by 2 j hat. Okay. Now what? Now triangle law we will apply that OA plus OB will be, sorry, OA plus AB will be OB. So this means OA plus AB will be OB. This means you will have minus 5 by 2 I hat plus 3 root 3 by 2 j hat. Okay. Clear? This will be your vector OB. Now the magnitude will be the answer, that how far is she now from its original position. Clear? In terms of vectors, you will have this. I hope that it is clear. Okay. Let us move next. Now fourth problem. If vector A is equals to vector B plus vector C, then is it true that the length of A will be same as sum of length of BC? Okay, let's see. Suppose you have a triangle ABC. In triangle ABC, you are saying that CB vector represented by small a vector, CA small b vector, and AB as you can see small c vector. Okay, this means by triangle law, what you can say that B plus C will be your a vector. Yes, B plus C. As you can see, B plus C will be your a vector. Okay. Now this means it is clearly known what, that the magnitude for A, B, C represent the sides, length of the sides of triangle A, B, C. Yes, and this is also known that the sum of any two sides of a triangle will be greater than the remaining side. This is what already written over here. So it is not true. It is not true that they are going to be equal to each other. Okay, not going to be true. Clear? As we are assuming, obviously, what, that A, B, C are non-zeros. Okay. Now fifth problem. Find the value of x for which this is a unit vector. The given thing is your unit vector. This means find the magnitude. You will have your, put it equals to 1. So you will get magnitude for this vector is equals to 1. This means root of 3 times x square is equals to 1. This means square both sides. You will have x value as plus minus 1 by root 3. So required x value will be plus minus 1 by root. Now sixth problem. Find a vector of magnitude 5 units and parallel to the resultant of the vectors A and B. Okay, so you have to find a vector of magnitude 5 units and which is parallel to the resultant vector. So resultant of the vectors A and B. Okay, let's see. So A and B is given to you. The resultant vector will be C. Resultant means the addition. So C vector will be A plus C. So resultant vector will be 3i hat plus j hat. This means the magnitude of this vector will be root 10. This means the unit vector will be C divided by its magnitude. This means this will be a unit vector. Now you know that the required vector will be parallel to this and having magnitude 5. So what you have to do, just multiply it 5 times, you will get your answer. So you multiply, either you can multiply with 5 or you can multiply with minus 5, you will get the same answer. That's why plus minus 5 dot product with C hat. So you will get this as your required answer. Okay, I hope it is clear to you. Okay, now what is happening? So this is that this will be what? Now seventh problem. A vector is this, B vector is this, and C vector is this. You have to find a unit vector parallel to this vector. Okay. So first of all, find this expression, this thing, this operations. So 2a minus b plus 3c will be 3I hat minus 3j hat plus 2k hat. The magnitude will be root 22. This means the unit vector along this that means parallel to this will be what? Just divide this vector by its magnitude, you will get your answer. Okay, clear? Now eighth problem. Show that the points A, B, C are collinear and find the ratio in which B divides C. B divides C. So let's see. 3 points A, B, C. AB vector will be 4I hat plus 2j hat plus k hat, 6k hat. BC vector will be 6I hat 3j hat plus 9k hat. AC vector will be 10I hat plus 5j hat plus 15k hat. Okay. Now what is happening? Now quite easy. That so what the things you have to do, that you have to show that the points are all collinear and you have to find the ratio in which B divides AC. Okay, so let's try to see. So as you can see, AB vector, okay, as you can see, AB vector is given 4I hat plus 2j hat plus 6k hat. Okay, this is your AB vector. Now divide this by 2. You will get what? 2I hat plus j hat. The scalar components will be 2, 1, 3. Yes, 2, 1, 3. Now multiply with 3. You will have 6, 3, 9. This means BC can be represented as 3 by 2 AB vector. This means they are parallel. Yes, BC can be represented as 3 by 2. BC can be represented as 3 by 2 times AB vector. This means parallel vector. Okay, I hope it is clear. Now this means AB and BC are parallel to each other. Yes. Now what? Now multiply with 5 here. You will have 20, 10, 30 and divide by 2. So this means AC will be 5 by 2 AB. AC will be 5 by 2 AB. So this means they are also parallel. If AC and AB are parallel and AB and BC are parallel, this means AC and BC are also parallel to each other. Okay, this means they are parallel to each other. Okay, now this shows that they are parallel. Okay, now what? Now their length, if you find their respective length, you will have 2 root 14, 3 root 14 and 5 root 14. This gives you what? The length of AC, the length of AC will be what? As you can see, AC will be AB, the length for AB plus length of BC. Okay, thus the given points ABC are collinear. Okay, now what about the ratio? So we are assuming that B divides AC in lambda ratio 1 form. Lambda ratio 1 form. Then we have OB is equals to lambda times OZ plus OA times divided by lambda plus 1. So put the respective things. You will have this nice expression. Okay. Now equate, or on comparing the corresponding components, you will have what? 5 times lambda plus 1 is equals to 11 lambda plus 1. This means lambda will be 4 by 6. This means 2 by 3. So the ratio will be 2 ratio 3. So your ratio will be 2 ratio 3. I hope it is clear to you. Okay. I hope it is clear to you. Now ninth problem. Find the position vector of R which divides the line joining 2 points P and Q whose position vectors are these given 2a plus b, a minus 3b. Externally in the ratio 1:2, also show that P is the midpoint of the line segment R. Okay. Now solution. As OP is this and OQ is this, okay, it is given that R divides a line segment joining 2 points PQ externally in the ratio 1:2. This means OR will be applying formula. You will have 3A plus 5B. This formula is for line segment. A point R divides a line segment in what ratio? The externally. If it divides externally, then the formula will be, or we have already seen such formula, so we just applied that and you will get OR as the position vector for R will be 3A plus 5B. Now position vector of the midpoint of RQ will be, just using the formula you will have this. Okay, this means RQ will be 2A plus B, which is same as OP vector. This means P is the midpoint of the line segment R. Okay, I hope it is clear to you. Easy. Now 10th problem. The two adjacent sides of parallelogram given, find the unit vector parallel to its diagonal. Okay, also find the area. So adjacent sides are, the diagonal of a parallelogram is given by A plus B. Yes, so A plus B vector will be there. You have to find out the unit vector parallel to this. So just divide this vector by its magnitude. You will get your unit vector parallel to this diagonal. You will have this as your answer. For area, you have to find the magnitude of A cross B. The A cross B can be found out by evaluating this determinant, and this determinant value will be 11 times 2I hat plus j hat. This means magnitude will be 11 times root 2 square plus 1 square. This means 11 times root 5. So area will be 11 times root 5 square unit. Now 11th problem, show that the direction cosines of a vector equally inclined to the axis OX, OY, OZ are these. Let's see. Let a vector be equally inclined to axes OX, OY, OZ at angle A. Their direction cosines of vectors are cos A, cos A, cos A. This means you all know this formula that cos square alpha plus cos square alpha plus cos square alpha is equals to 1. This means 3 cos square alpha is equals to 1. This means cos alpha is equals to 1 by root 3. This means the direction cosines of vector which are equally inclined to the x-axis are 1 by root 3, 1 by root 3 and 1 by root 3, as you can see from here. Yes, plus minus obviously, as it is already given that cos square is equals to 1 by 3. This means cos alpha must be plus minus. We are talking about plus minus terms. Okay. Now 12. A vector is this, B vector is this, C vector is this. You have to find a D vector which is perpendicular to both A and B, and C dot D will be 50. Okay. So D vector is this. If D is perpendicular to AB, this means dot product of D A will be 0 and DB will be 0. This means D1 plus 4D2 plus 2D3 is equals to 0. 3D1 minus 2D2 plus 7D3 is equals to 0. This is already given to you. This means 2D1 minus D2 plus 4D3 is equals to 15. On solving 1, 2, 3 equations, this means this equation, and this equation, you will get D1 as 160 by 3, D2 as minus 5 by 3, D3 as minus 70 by 3. This means your D vector or the required vector will be 1 by 3 times 160 I hat minus 5 j hat minus 70 k. Okay. Now 13th problem. The scalar product of vector I plus j plus k with a unit vector along the sum of vectors 2I hat plus 4j hat minus 5k hat and lambda I hat plus 2j hat plus 3k hat is equals to 1. Find the value of lambda. Okay. So your sum of these two given vectors will be what? 2 plus lambda I hat plus 6j hat minus 2k hat. Okay. Clear? Now therefore unit vector along this vector will be what? Just divide this vector by its magnitude. The magnitude will be find very easily by using just this. You will have this as your unit vector. Now, the scalar product of this with this unit vector is equals to 1. So, mathematically, the I plus j plus k dot product with this vector gives you 1 as your output. Simplified, what you have is 2 in numerator, 2 plus lambda plus 6 minus 2 divided by the magnitude is equals to 1. This means simplify more, you will get 8 lambda is equals to 1. This means lambda value will be just 1. Okay, lambda value will be just 1. I hope it is clear. Now 14th problem. If A, B, C are mutually perpendicular vectors of equal magnitude, show that the CD vector dot product of CD is equals to 15 is equally inclined to A, B, C. Let's see. So A, B, C are mutually perpendicular. This means dot product will be 0. This means AB dot product BC dot product CA will be 0. And also given that the magnitude, their magnitude must be same. This means magnitude of A, B, C all same. Now vector A, B, C. Okay, as you can see this question. Vector, you are taking vector A plus B plus C be inclined to A, B, C at angle theta 1, theta 2, theta 3 respectively. This means cos theta 1 will be this divided by its magnitude. Cos theta 2 will be this divided by its magnitude. Cos theta 3 will be this divided by its magnitude. You will have cos theta 1 as this value, cos theta 2 as this value, and cos theta 3 as this value. Okay, I hope it is clear. Okay, now as their magnitude are same, okay, now what? Now cos theta 1 is equals to cos theta 2 is equals to cos theta 3. This means theta 1, theta 2, theta 3 must be same. Why? Because theta 1, theta 2, theta 3 belongs to 0 to pi interval, and in 0 to pi interval cos is what? 1, 1. That's why it will happen. Hence this vector, the vector we have assumed A plus B plus C is equally inclined to A vector, B vector as well as to C vector. Okay, now 15th problem. Prove that the dot product of these two vectors will be square of magnitude of A plus a square of magnitude of B. If and only if A and B are perpendicular, given that A vector and B vector are non-zero vector. So let's see. So this dot product will be using just distributive property. You will have this A dot A plus A dot B plus B dot A plus B dot B equal to this. Now this can be rewritten as square of magnitude of A. This can be rewritten as the square of magnitude of B. You know the dot product are commutative. This means plus 2 A dot product B. You can write this. Now this magnitude from the left hand side and from the right hand side you can directly cancel. You only left with 2 multiply A dot B is equals to 0. This means A dot product B is equals to 0. And this gives you, as it is already given that both must be non-zero vector, this means the only possibility will be A and B must be perpendicular to each other. Okay, that's what we have just shown. Clear? Now 16th problem. If theta is the angle between two vectors A and B and the dot product is greater than equals to 0, then the possible range theta can take, or theta will lie in what interval? Quite simple. Theta is the angle between A and B vector. Okay, without loss of generality, you can take A and B as non-zero vectors. Okay, now what? Now the magnitude of A and B are positive. You all know that. Okay, it is known that A dot product of A and B is same as product of magnitude of A and B times cos theta. Okay, this is already given that dot product is greater than equals to 0. This means this must be the greater than equals to 0. Okay. Magnitude already positive. This means cos theta is greater than equal to 0. This means theta must lie from where to where? 0 to pi by 2, including 0 and pi by 2. So this means option B will be our correct option. So closed interval theta must belongs to closed interval 0 to pi by 2, or in other terms, this B will be your correct answer. Now 17th problem. Let A vector and B vector be two unit vectors. So both must be unit vectors, and theta is the angle between them. Okay. Then A vector plus B vector is a unit vector if. So you have to find out the condition where this must be your unit vector. It is already given that they must be unit vector. This means magnitude of A and magnitude of B must be 1. It is already somewhat given to you that the sum of A and B and its magnitude must be 1. This means magnitude, if magnitude is 1, this means you can write this magnitude as dot product of A plus B with itself. Okay. This means what? Now distribute by using distributive property. You will have A dot A plus A dot B plus B dot A plus B dot B. A dot A means square of magnitude of A. B dot B means the square of magnitude of B. This will be 2 times A dot B. As you know that magnitude of A and magnitude of B both equal to 1. This means 1 is square, 1 is square. Now you will have what? That cos theta is equals to minus half. This means theta must be 2 pi by 3. Theta must be 2 pi by 3. Okay. This means the condition for which you will have the A plus B magnitude equals to 1 will be when theta must be 2 pi by 3. So option D will be your correct option, as theta must be 2 pi by 3. Okay, clear? Now 18th problem. The value, you have to find the value for this. Quite simple. So as J cross K, you already saw that J cross K must be I hat. I cross K will be minus J hat, and I cross J will be K hat. This means I dot I will be 1. J dot minus J can be rewritten as minus J dot J, and K dot K will be 1. This will be 1. As you can see, 1 minus 1 plus 1, this can be just 1. So your value will be C, also 1. This means C will be your correct option. C. Okay, now the last problem of this miscellaneous, and okay, so if theta is the angle between any two vectors, vector A and vector B, then the magnitude of dot product of AB is equals to the same as the magnitude of cross product of AB. Okay, so you have to find at what condition this will happen. This means what must be our theta in such case. Okay, so put this thing, express in terms of, or expand in terms of normal concept. This means what? So what you are assuming? You are assuming that A and B both are non-zeros. Okay, so magnitude of AB means magnitude of A multiply magnitude of B multiply cos theta. Okay, now magnitude of A cross B will be magnitude of A magnitude of B sin theta. Okay, now cos theta is equals to sin theta. Yes, this means tan theta must be 1. Yes, this means theta value will be pi by 4. Yes, so the only condition when this is going to happen, that the magnitude of dot product of AB will be same as the magnitude of cross product of AB. This can only happen when theta is pi by 4. So option what? Option B will be your correct option. Pi by 4 means 45 degree in degree, and in radian pi by 4. Okay, I hope it is clear. So this is, as you can see, uh, this was the last question of this exercise. So this is it for now, and also for this chapter, that we have ended our concepts, all the theory and the main exercises from this chapter, Vector Algebra chapter 10. We will be back with the next chapter. So thank you all. We will be meeting in the next lecture. So again, thank you.